types of flames used in flame emission spectroscopy. So we are going to describe it with the detail. First of all, I start with the use of burner in the flame emission spectroscopy. The burner is used in flame emission spectroscopy to provide the energy of excitation in the form of the flame. The energy of excitation that is required to excite the atoms to a higher unstable state. Flame is produced through the burning of the oxidant and fuel. Next कीजिएगा जरा. Now, what is burner? The flame used in the flame photometer should possess the following function as explained below. The flame which we required or the burner we required must have the properties as shown below. The flame should have the ability to evaporate the liquid droplets from the sample solution in the formation of the solid residue. The flame should decompose the compound in solid residue resulting the formation of the atoms. The flame should have enough energy to excite the atoms formed and cause them to emit the radiation energy. Means when the atoms are excited and when they de-excite, it should have the energy that the atoms should come back to its original stable state while emitting the energy. Next कीजिएगा शादी. Okay, so here are the types of the burners. There are following types of the burners: Maker burner, total consumption burner, laminar flow burner, Lundergraf burner, shielded burner, and nitrous oxide acetylene flame. This is the type of the flame that is used in the burner mostly. We'll start with the Maker burner. Maker burner or Maker burner is the same pronunciation but with the different spells. This was the primitive type of the burner used in the flame photometry. It's the most ancient type you can say of the burner that was used in the emission spectroscopy and was used earlier. It generally worked with the acid of neutral natural gas and oxygen as fuel and oxidant. These were employed respectively as the fuel and oxidant. The temperature so produced in the flame was relatively low, resulting in the low excitation energies. The flame produced with the Maker burner was of low energy, so it was not used for the highly stable oxides to excite them to the higher energy state. Nowadays, it is used. It is not used, but it was best suited for the alkali metals because they have low ionization energy, so they can be excited easily by the use of this Maker burner. Okay, the next is the total consumption burner. As the name implies, the word total consumption, the oxidant or the fuel is totally consumed in it. Due to high pressure of fuel and oxidant, the sample solution is aspirated through the capillary action and burned at the tip of the burner. Through the capillary action, the fuel is transferred to the tip of the burner where it is burned. Hydrogen and oxygen are generally employed as the fuel and oxidant respectively. The advantage over other is the entire consumption of the sample. Means as I said in the start, the total fuel and oxidant are consumed in this burner. So here are some advantages and disadvantages of this burner. Advantage: the design is simple and the whole sample is consumed, so there is the no waste of fuel. Disadvantage: uniform and homogeneous flame is not obtained since the droplet size vary, leading to the fluctuation in the flame size. Means the flame we are receiving at the tip of the burner is not consistent. Its size varies according to the size of the droplet, as we are receiving the variable size of the droplets due to the capillary action. Next कीजिए. The third one is the laminar flow burner. You can see the diagram. It is also called as pre-mix burner. This is called pre-mix because in this burner, the fuel and oxidants are pre-mixed before going to the tip of the burner, so they are thoroughly mixed. And from here, my team member will continue to describe you, Kashif Hussain.
Laminar flow burner. In this type of burner, the aspirated sample fuels and oxidants are thoroughly mixed before reaching the burner opening and then entering the flame. The most important feature of this burner is that only small portion of the sample reaches the flame in the form of small droplets and easily decomposed. Shaji, next कीजिएगा. Here we have to discuss some advantages and disadvantages of this burner. Pre-mix burner is non-turbulent, turbulent, noiseless, and stable, and easy to use. Easy decompositions, which lead the high atomizations, can handle the solution up to several percents without any interferences or clogging. The main disadvantage of this burner is that when it's contain two solution, the more volume solution will evaporate first, and lesser will remain undissociate. शाजी next कीजिए. Here we have flames in FES. Here we have some elements which emitted wavelength and their ranges and observed colors. Potassium 766 wavelength and color which is shown on the flame is violet. Lithium 670, calcium 622, sodium 589, barium 554. Next कीजिए. The structure of flames. Flames, as seen in the figure, the flame may be divided into the following region zones: preheating zones. Preheating zones, the most closest zone to the wick. Primary zone or inner zone, the middle part of the flame, the biggest part of the flame. The internal or secondary reaction zone, the outermost part of the flame, and the most hottest part of the flame. So the next कीजिए. Here, the flame which is used in the FES, first one is nitrous oxide acetylene flame. The flame was superior to the other flame because of their temperature range. Its temperature is 2955 Celsius and producing effectively free atoms with very reflective oxides such as aluminum and titanium. The drawback of this flame is the high temperature reduce its usefulness for the determination of alkali metals as they are easily ionized. And the next one is air acetylene flame. The temperature range for the air acetylene is 20 to 50 Celsius, and the limitation of this flame, it is unable to receive the heat stable oxides, not used for the wavelength less than 200 nanometer. The third flame which we used in FES is argon hydrogen flame, does not absorb a wavelength of less than 200 nanometer. And this flame is useful for those elements which contain wavelength less than 200 nanometer. Like examples are arsenic 193 nanometer their wavelength, and cerium 197. Now that's all from my side.